going back to the notebook, I know this is, I'm just setting up here some stuff that we need in order to move on to the next bit, which is looking at the schema itself. And Raphael, do you want to speak a little bit about just the kinds of schemas in Dgraph? And
sure. So as I said, we have two ways of using Dgraph. You can start with, it's a schemaless database, so you can really store anything like the name of a thing is Raphael, you store it as a triple and you will get it. So that's the basis of the knowledge part. But you can also see other people like application developers who are really onto the schema and driven by the fact that the schema will be also used at the front end to be sure about the data that you have to display on every screen. So you can completely start in Dgraph by a schema and defining a GraphQL schema that will generate automatically the GraphQL endpoint for you. So that's an interesting way to have also collaboration between people who usually have disconnected sources, the application developers who ultimately feed the data into the knowledge graph at one point, and the data science people or business people who will work also on the data, add metadata, add information on top of this schema-oriented initial graph. So that's the way we will experience into this one.
great. And when we set out to build the schema for the Offshore Leaks database, it's important to kind of look at some of the questions we want answered first. So in doing the schema design, you kind of, at least what we try to do is look at the questions that you want answers to, and then build the schema around that. In this case, we wanted to obviously allow for text searching and some basic things like that, but we wanted to be able to do like a regex search or trigram searching. We also wanted to do a shortest path analysis. So because every and I'll go here to the actual schema itself.
Excuse me.
Yes.
I don't think the screen that you're showing on the screen is the one that's being shared.
Oh, really?
Yeah.
In AirLink? Oh, sorry. Share this tab instead. Yeah, I keep going between tabs. I got you, Kevin. I see what's going on now. Do you see it now?
Yes.
Okay. So this is the actual schema. This is the GraphQL schema definition language file that we used to build the data set. And SDL, GraphQL SDL standard, and we support that fully along with lots of things like we have directives that you can apply to predicates, such as the source ID to be able to do an exact search, by that hash search, or you can do a full text search against the notes, for instance, which would be a stem search. So this is the schema that we've built specifically for GraphQL, and GraphQL schema supports the use of interfaces, which is very handy. So in this case, we have this base record, which is anything in the entire graph. And then we have entities, and they inherit, if you will. Record, we have intermediaries, we have addresses. So they all kind of come together and form the actual schema that we're going to use. And right now, if you're using one of the EC2 instances, right now your cluster, your Dgraph cluster is up and running in system D, but it hasn't got anything yet. So this is the first time we're going to interact. Sorry, it's been we're on time. So just execute this cell. And for those of you who don't know or don't use Notebook, there's a little play button up here. Sorry, I'm going back to sharing the tab. I think we're back now. Okay, so I'm sharing the right tab now. There's this little play button here, or you can also command return to run a cell. So right now our cluster now has a schema that we just applied. And this next thing I want to do is now I'm going to load. So we've taken a subset of the couple million entities, and this subset is now, we're going to load this subset into Dgraph. So if you execute this next cell, it will start the process, and this will take about a minute or so. And we'll see sort of some output. Raphael, you can speak a little bit about this.
The data loading, it will start. So In terms of the data representation, if you talk, as I say, to the application developer, they will see more the JSON representations, and with the fact that it's nested, and the nested representation of the JSON is a tree and it's a graph. So we can totally get JSON directly, and it will populate graphs and will create relations. So you can see also Dgraph as a way to explode a JSON and not only store a JSON document, but actually the complete graph. So you can go at the predicate level in terms of queries and analysis. But as I said, we also support triples and the RDF format here. And in terms of loading, we can load directly to disk very efficiently with a MapReduce algorithm to split under the different clusters. So it will be super fast for initial loading, for example, of massive data set. Or we are using what we are doing today, it's a live loader. So that means you may have data or not. In our case, it was empty, but you don't have to stop the cluster and you can just interact with it and load the data. And so there's two ways depending on your situations. And also you can obviously load through the GraphQL API through mutations, but it's another way to do it.
In this case, we were processing nearly 28,000 enquads per second when we live loaded. Live loader is the slowest of the two. Bulk loader can do a massive transaction speed. Yeah. So okay. So now, if you're following along, our graph not only has the schema, but it also now has all these subset of the data now loaded. So finally, we're going to do some Python coding here. Sorry, it's been so long. If you execute the next cell underneath imports and other housekeeping, it will load a few things that we're going to be using. Pandas takes a little bit to load. So that was this is obviously for those of you who don't know, this is Python. And now you can add that to your resume if it's not there already. So we've just loaded some, like I said, this is just a placeholder, like getting things staged. And before we launch into some queries and mutations that Raphael's going to talk about a bit about kind of the two flavors and how we kind of support things around it.
Yeah, in terms of clients, as we said, if you start with the GraphQL part, we follow the specifications, so you can take any clients doing well with GraphQL, Insomnia, Postman, whatever you choose. And we support introspection, so the tool will be able to get the schema and infer also all these queries and mutation operations that you have. And the second way is to interact with a Dgraph query language. As I say, GraphQL is very schema-oriented, so it will follow exactly what you can do with the predicates associated with each type. But at the lowest level, we are agnostic, so we can search any, for example, node which has a name, and we don't care about the type. So at the Dgraph level, we can do more things. So we have this Dgraph query language that will allow you to interact directly with the predicates and the nodes and the relationship. And we are exposing this as client so today in Python and in any language that you need.
Thanks. Kevin, I think I messed it up again. Sorry. Every time I switch tabs, it seems to do something. It's working fine in here, but I don't think people at home can. I think I missed it. Can you see it? Is it showing the right?
So,
for some reason, the sharing thing just went away. I keep
we
pressing.
should be ready soon to get our first query and use the client to get some data from the graph, and then explore a bit.
This tab right there. And then just hit share.
Yeah, sorry for the interruption. So so this next thing is this next cell. If you execute this next cell, basically, we're doing two things here. We're importing PyDgraph. That's Python's official, or Dgraph's official Python client. And then we're just using a generic GraphQL client for Python. This is a very popular one. So we now have these two clients available to us that we can do things with. The first thing we'll do is like our first query. We'll just run a query against the data set that we imported, and we can just get a count of the records in this graph, based on the source, whether they come from Paradise Papers, Panama Papers, Bahamas Leaks, what have you. This next cell will actually run another GraphQL query, which will do full text So when we set up the schema, we indicated that we wanted names to be a full text search. And in this case, in Dgraph, that means removal of stop words and using stemming. So we searched for the word live here, and we get all those versions from the graph which contain the same stem, like living. So that's an example of doing a full text search. We also support trigram or regex searches. So if you were to execute the next cell underneath the regular expression query, you would see we're developing a case insensitive search against two terms against our regex or our trigram indexes. And that kind of gives an example of the wall time here. It's pretty speedy, which I think is kind of cool. All right, so the next thing we're going to do is this next cell is just setting up some definitions that we're going to need. So Raphael mentioned it earlier. It's oftentimes, when you get results back from Dgraph, they come in nested JSON. You have this JSON that's returned, and if you're navigating edges all the way through relationships, then it could be extremely long. And doing analysis and visualizations in graphs tends to be done in dictionaries of nodes and arrays of edges. So we need some way, and this is just a little convenience function that takes any JSON document that's nested, and provided it has an ID in it, can extract all the nodes and all the relationships. So this, if you execute this, it's just setting up that function in order to do that. The next function is, if you go to the next block and execute that again, it's another definition. So here we're just setting up a technique to query using multi-threading so that we can get faster results from the query. And then finally, this underneath where it says load all nodes and edges, if you run that cell, it'll actually start using half the cores to query all the records that were imported into the cluster that's on your machine. So now we have a node count of over 150,000 and an edge count of nearly 100,000. At this point, I forgot to mention that when we exported the data, we just chose random relationships from our graph. So it's what that probably is. Spoiler alert! What it actually did was create a graph that's not well connected. So we're going to use some graph analysis now to actually kind of connect the graph back together.
So when we're with the nodes and edges that we just set up,
right?
That's in the Jupyter Labs context.
It is.
Right.
Yeah. That's right now in this context. So Dgraph, when it returns its results, are always going to be JSON.
Yeah. Okay.
So you're actually declaring, like in GraphQL, you declare.
So it's querying the server. It's bringing it back to the Jupyter Labs process space, and it's doing all this in-memory manipulation in the Jupyter Labs process.
And we've just turned it into dictionary of nodes and array of edges. Gotcha. Exactly. These next two steps are just moving these, what we're just talking about, these nodes and edges into pandas data frames, and we're doing that now. We just have a little sample of what they look like.
Yeah, so just to reply also to this question, so the first thing was the queries. Just to explain that you can limit also, if you have a very, very large graph, you can do the DQL and the GraphQL queries, so you can get exactly what you want to analyze. And then at one point you can transfer to a UI tool or another.
Yeah, and in this case, we'll go through it a little bit more further. So now we've got all the data in our entire graph, which is a subset of what we initially looked at, but we didn't realize we would have 16 core machines available to us. So now we've got a subgraph, and we can use, this is sort of an example of how you can use results from Dgraph, kind of pump them into network analysis tools like NetworkX or iGraph. In this case, we're using NetworkX. It's been around forever. A great Python graph analysis package. And here, if we execute that cell, we'll get a sense that this density in the network, is very, very low, meaning it's not a well-connected network, and we're trying to get the diameter, which is the longest, shortest path. actually results in an error because it's not well connected. So what we can do is we can do a few things to get another subgraph. Just keep working down, keep whittling down our graph, and we can have a look at just getting the top 10 nodes by degree. That's kind of interesting. Degrees being the number of connections in and out. We can also look at PageRank. That's probably a more useful algorithm supported by NetworkX. So now we have all the entities sorted by PageRank, and we're displaying the top 10 here. And if we go to the next cell, just to do a little analysis, just look at the distribution of, this is the entire set of records. You can see that the PageRank, it's really skewed heavily to the left. There are not a lot of records with a good PageRank, but if you go to the next cell and execute that, you can see that there's a little bit better distribution in our top 150 nodes. So what we're going to do now is just load, as an example of going back to Dgraph now, with information that we got through network analysis. We're going to go back to Dgraph and say, we're going to issue a recursive search. This is the recursive search. And we're going to say, out of that list of 150 top page ranked individuals or entities, rather, can you just issue this recursive search and then give me the results? And this is what we'll do next. So less than a second to do that. Very deep search. Now we've reduced our graph once again to 14,000 nodes and 28,000 edges. So at this point, I'm always this way. It's like, okay, I'm working on a graph, and like I want to see it. I want to see my graph. So it's like that's a thing that like a lot of people want to do. And we're working with Graphistry, and we've come a long way in the last couple months to actually do this. So I'll explain this just a little bit. Right now, so Graphistry has a free tier that for most needs is plenty. We do have some dedicated GPUs here serving you today, but if you're just doing this on your own, you could use Graphistry like this inside a Python notebook with no problems whatsoever on pretty large sets of data. So what we're doing here is we're taking the data frames that we just converted. We pulled that using PageRank analysis. We pulled a subset of our graph, and at this point, we're going to kind of use Graphistry to understand it and look through it. And what we can do now is this is just stuff that sets up Graphistry nodes, data frame, edges, and then you tell which attributes in that array of records are the important ones as far as the edges are concerned, the links. And then we're just doing some stuff where we change some colors and we add some icons and whatnot just to make a nice graph. So you're probably already way ahead of me because you're like bored to hear me talk. But here's the graph, and it should render up pretty quickly.
Graphistry running as like a plugin for Jupyter Labs in this context?
It is. Yeah, they have a Pi Graphistry thing that we're running. So we were able to set it up this way, and then this is you can kind of see the graph here. There's a little thing over here to the upper right of that visualization, which will open in a new window, and it's a little bit easier to see. You have to press on the thing here. Well, what's cool about about Graphistry is that this rendering is being done on a GPU remotely and being sent to the browser. So when you're dealing with trying to understand millions of edges, it's sort of impossible to put them all into a browser space. So here we can kind of zoom in, and you can start to see some communities. Oops, I'm making a mess of this mouse. Let me use the tools over here. You can zoom in and start to mess around. You're probably doing this right now as I speak because it's so fascinating. We can have a look here at, like for instance, this is one of the people in our PageRank we saw. This was a intermediary, and if you have a look, it's like really kind of crazy just to see some of the relationships. One of the great things about Graphistry, in my opinion, is that you can then, I just selected that intermediary, and now I can, what's the command here? I can hardly see it. I should put my glasses on. So I can do a selection expander. I just toggled that little thing to the right, and now I can start moving out with connections. at this point, I could filter just that and do an analysis of that. Let's say that was the active set. I could then go and add a histogram for like whatever, not only attributes of the graph itself, if there were scalars, for instance, in the graph, but also you can, create histograms for the number of, the degrees, edge types, for instance, or the node types themselves. So GraphStery, it's a really great tool. And yeah, we're happy that we're able to, to work with them now. They've been very helpful for us. All right, so I'm going to go back. I know that's, I probably spend like 90 minutes there alone because it's kind of fun and exciting. But I'm going to go back to my tab because we do have a few more things we want to talk about. Back to the notebook now. So shortest path query is something that Dgraph supports natively. And you can ask a question like, is there any connection between the Duchy of Lancaster, and this is the entity which controls the King Charles's money, for instance? Is there any connection between that and this rando address in Bermuda? You probably know the answer to that question, I'm guessing. Yeah, so you can run this path here, and we'll just, if you execute this cell. Pizza delivery. So this is the results of a path search in Dgraph. It's giving you the closest link between these two entities, and of course, everyone probably knows what shortest path is in this room. But this all kind of dictates, or kind of shows exactly how the relationships are formed through the edge types themselves. And then I just kind of print out the things. I don't know why I just did. Here's some utility. This next cell is just some utility stuff to convert these results into Cytoscape. You might know Cytoscape. There's a JavaScript version of Cytoscape. There's also a notebook version with Python bindings, and it's good. It's kind of fun. You can use it. And this next cell actually just visualizes that shortest path relationship between the Duchy of Lancaster and that rando address in Bermuda. And this just shows an example of how you could use Dgraph to support the visualization of this kind of nature. All right, time check. All right, not bad. We're doing well. So the next thing that Raphael's going to cover is how we do geolocation stuff.
Briefly, when we create the schema, that you can add indexes for search, trigram, and different things. So we can support also indexes for geolocation. So we support points and shapes and functions to detect, to search by intersections or proximity. So that's what we are using here, because this data set has some interesting locations and points for the addresses. So that's also supported in Dgraph. And we are trying to see also what is needed in the future in terms of indexing and search capabilities for other types. I'm interested in your feedback if you have specific data.
Yeah, I forgot to mention that when we did the RDF, so the data that we imported into Dgraph was RDF. And during that phase, we found every US address that was in the Offshore Leaks dataset, and we geo-encoded them using the US Census Bureau's REST endpoint for doing that. It's pretty good. We got like 70% success. So those we converted into lat longs, and those were also imported when we imported the data that created the initial cluster.
And that's also good to mention that you can always augment the data with additional data sources. So far in data, these data sources and the locations.
Yeah, in fact, they're just kind of like sometimes just weirdly, formatted long strings of like what they think is an address. Yeah, so unfortunately, it's not a really clean data set. But so here we can, if we execute this cell, this just does a query through every address that actually the filter here we see here is quite straightforward. Does it have a location? Location is the geo point. That's a predicate that we have in every address. that basically says it's a geolocation entry. If it has it, then we're sampling 5 random ones that we created in a data frame of the results. So now in this next cell, little razzle dazzle again, we can show those locations in a map, and this is just showing every single location that's in the subset, kind of plotted in the United States. If you hover over some of the icons there, you can kind of see kind of pop up, the actual addresses that are located in that area, and then what officer or entity or intermediary those addresses correspond to. The next tab is kind of taking it to another level or another space, which is just give me a query of all addresses within a 50-mile radius of Syracuse, New York, and we just show the results and just give you an example. Some of the kinds of geoquerying you can do in Dgraph, and this is just using a Google Maps API to kind of show that off.
Did you guys have a geospatial index that you applied to part of your data?
Well, we imported we imported the RDF data, which included lat long, and we have a native geo indexing.
Does it detect that lat long, or do you have to? Is there some nominal configuration that's required?
It's just the type. If you give it a type.
Okay.
Yeah. So actually, it's a RDF. The RDF.
It's the RDF type.
Yeah, type GeoJSON or whatever is the RDF type.
GeoJSON.
Right. If it sees that, then obviously we apply it in the schema that we built. But you can also just import that. It's schemaless. Dgraph is schemaless, and it will see that, and it'll create indexes on it if you want. If you go back and create the indexes. All right, so the next thing we're showing off is just something we've seen before, but I want to talk about it a bit, is recursive queries. Obviously, it's one of the basic functions that any graph should be able to do. And this first cell under recursive queries is just setting up. Again, we're doing some data munging to convert things to formats, which is all very exciting, I'm sure. But the idea here is that we want cytoscape to be able to display. And at this point, what we're doing is this next cell. Did I execute that? Okay. This next cell is just basically doing a recursive search using this node ID. This happens to be a very popular address in Tortola. And what we're doing is a 5-depth recursive search. And we're looping through these edge predicates in order to get, going deep, 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 deep as far as we can, well, at least in 5 depth. And here, I run that cell. This is what you get. So another example of using Dgraph along with some visualization tool. Pretty simple to do. And the final thing we're going to do is look at mutating Dgraph, or kind of using it not just as a read-only source of analysis and working on information or a graph, is actually maybe using it as a shared knowledge graph that you actually, an organization might be using, a live thing. So this next cell, what we're going to do is we're going to update the schema. I'm going to just briefly show the change in that schema. So we have a new schema here, which all it's doing is it's just adding this attribute, which is a flagged attribute. So we'll just apply this, and it automatically comes into the space. And what the idea behind this, it's just completely made up, is that if you flag an entry, maybe you put your email in there, that I'm flagging this for some reason, and that's sort of the idea behind that thing. So I'm going to execute this cell now, and it takes no time. It doesn't have to rewrite, everything. It's automatic or very, very quick. So now that we have a new schema, and this next thing, what I'm going to show is using an interactive.
On this one, I just wanted to add that because we are schemaless at the storage level, the schema is just a way to see the data, so we can rapidly change it, and you can still use your data. So we don't have a downtime to change the schema. You just declare something on top of it.
That's true. This next cell is just setting up a data like a UI handler here, where if you click on one of those nodes in that graph, it's actually mutating Dgraph. It's going to your cluster, and it's updating the flagged that flagged attribute that we just saw. It's basically dumping your email in there, or my email, if you don't change it. So I'm going to execute that. That's like I said, the definition. And here I'm going to actually execute the next cell, which is basically the same thing as we did earlier. And now it's just getting a new graph, which has the definition where if you click on a cell, now it's turning red. That means that I'm flagging these entities or records or whatever in the graph, and now I'm indicating that. So this is mutating the graph. So anyone else who's looking at your graph could see that these individuals or these entities have been flagged for some reason. And finally, what we'll do is we will issue a query. This time, the query is just to recurse through all flagged records in the graph. And when I execute that cell, it's showing, it just pulled out every flag, and then it's doing a recursive search against any entities related to those flagged records and showing them on the graph. And of course, you can just keep diving. You can just keep adding more and more. All right, so that's it. You're now Python programmers, and you're experts at using Dgraph with Python. And Raphael's going to close with some remarks.
Yeah. So first, we have the booth here, so happy to talk about also your feedback. That's the first time we try something very interactive, and we say less slide and get people working on the data. So happy to get your feedback on the booth. And what I wanted to say is, part of what you have seen is tools around the data, and part is what Dgraph is doing. But at any point in your journey with a knowledge or your data, you will have to store it. So that means if you have a graph database, you're removing a lot of the extra steps that you have to do to get at this point where you can really understand and act on your data. So for example, we already have the graph, we can query it as a graph, and we can extract it as a graph. So we don't have translation layers everywhere. So you can just spend your time on what you want to do at the business level. And then it's up to you to create new UI. So we work on Python today, but we can show you different things we've done also on the React.js using GraphQL, whatever the type of UI you want to use. And the key point is you can start by putting all your data in Dgraph. You can use it to clean your data, analyze it. That's what Matthew did. We didn't cover all the steps, but you can find the data missing, and so you can really use it, and it's very effective at that because you can work on a very large scale and a large amount of data. So you get curated data, and on top of that, you can see which API you want to expose. So you can also have an API for your business. You can still get your knowledge graph for your data science. And then it's also open, as you said, we are open source, and we will continue to be as open as possible with following the different specifications around. And you can plug any tools that you want on top of Dgraph to do your analysis. And you can do your automation, because now you can write back to the graph. And the next level we didn't cover today, we are event driven, so you can also have the event on the change data capture, so you can see when the graph has been modified and react on those events. So what we want to implement at the end is this kind of, when you discover something, you can implement it as a graph rule and get alerts. So as I say at the introductions, those kind of fraud detections, opportunity detections, recommendation engine that you can build with the graph after understanding what's in your data.
That change data capture you're talking about, is that a future capability, or
it's a future capability? So you can get notification on Kafka through any change in the graph,
or raw files too. You can just do a raw file capture as well as copy.
So then Dgraph, would Dgraph be the source of this CDC? Yes. So when mutations happen within Dgraph, then it admits.
Right. If you want to do the inverse, then you just write it,
right,
and then mutate Dgraph. We have people that do that. Yeah, and I also wanted to point out, Dgraph cloud.dgraph.io. This is, obviously you can pay for this, but also there's a free tier. It's really generous. I've had clients use this up until deployment. There's a really generous tier, a free tier here. No, yeah, I know, but it's all open source and everything, and like you can put it on Kubernetes or put it in systemd or whatever. But yeah, there's a cloud here. You can totally. It's like I said, it's got a really nice free tier, really capable. I mean, like only reason I do it is because sometimes it's just like Dgraph's really simple. It's like just one executable. It's written in Go. You compile it down into just one binary, and that one binary serves everything. You can put it in systemd. You can just run a command line. You can put it in Kubernetes. You can put it in a Docker container and run it with Docker Compose or Swarm, whatever. It's like really flexible. There's no like JVM madness to deal with or anything like that. It's just one binary that's native to the operating system in which you're deploying it. So it's really flexible that way. Like what we saw today, the EC2 instances that you guys just spun up, it was implemented in systemd. So it's just configured in Linux's systemd. And whenever the system comes up, Dgraph is there. The cluster is ready for you. You could have multiple machines all running systemd and run the cluster that way distributed. We have templates to do all that kind of stuff online, all open source.
And then you said driver-wise, like language support, the native ones you support are Go, Python, and then you have the JSON output. Is that right?
And we have an intro client, we have JavaScript client,
Okay.
client. The other one on gRPC, the Go and
There's .NET as well. We got a .NET.
and there is a .NET.
Yeah.
We're not giving that as much love as we should. But yeah, there's a .NET
If there is some
and
traction-
Java
And Java.
and C.
Uh,
I don't think we support it, but there's one that's used. C++.
we need to check if it's the official.
It's not official.
The support distributed, but is that only for distribution of load within a single cluster? Or do you do anything with distributing or querying information which is stored by different organizations independently? Do this sort of distribution, or is it only for load?
Yeah, I mean, really the idea behind Dgraph initially was just for load, like to scale a highly distributed graph, right? But since then, we have examples of Apollo Federation working. So it's I don't think it's like 100% baked, but it's there, and we're working toward it. So you're talking about just Dgraph being part of a larger,
Because
organization
federation of
and federation. Yeah. So we do support that. Yeah, you can wire it out. And we also have Lambda support. So if you needed to integrate an external source into the result set, we have all kinds of Lambdas, local as well as externally linked Lambdas. You can go out, grab information, and combine it in the results of in the result set. So that's something you can do as well if you want to integrate something smaller, into the result set of your graph.
slightly different question to me. So you're doing GraphQL. What is the reason behind why not something like GQL becoming the standard cipher? What is the advantage of using GraphQL?
The GraphQL came also from the application development part and pushed to the simplicity of consuming data. So we wanted to be able to address this market, as I said, just to because what we noticed is we have graph used by experts and not by the people doing the application. And the application usually are the one feeding the data. So you enter the data and the records and then finish into a table somewhere, and then someone is trying to use a graph on top of it. So we really try to see what can we do to get the graph used as a system of records. So that's why also we try to get to this application development world and expose the GraphQL API that makes more sense to them. But we are working on, DQL is our internal one, and we are working at getting a pluggable architecture. So if there is a huge request on OpenCipher, we can implement OpenCipher. It's on the roadmap to study. So if you have ideas about which one should be there, it's interesting for us.
Thank you.
All right, we said just before lunch, if no one else has any questions.
Are there, what are the limitations on the open source version?
So we have enterprise features, which are not open source. So access control list, multi-tenancy, encryption at rest. What else? And
A few other things too, yeah.
a few others. So that's the kind of things. But the full functionality of the search GraphQL is on the community.
And there's be no limits. You could make it as wide as you like. Exactly. There's no limits from open source from how far you can scale. There is a max UID limit that's implied when you first spin up Dgraph that you might run into when you get to, I don't know what the number would be, but just imagine, 20 billion edges or something. You might start running up against. But by then, if you've got that many edges, you're going to want some help probably because it won't, nothing ever comes up that easy. 20 billion edges.
And there are things that will make your life easier on cloud. So for example, everything we did there, the GraphQL component, you can do with the UI on cloud. But as you saw, you can just use the API of the community and deploy this.
And the observability monitoring
That's true.
It's another.
is the enterprise.
But that's available in the cloud. But we have Helm charts, everything for doing observability that's open source. It doesn't require you to use the cloud. You could monitor it using whatever you use. Whatever you use for.
PLG, Prometheus, this operator. Thank you.
All right. Well, thank you guys for coming.
As I said, we are here for the 3 next days. So if you have any also ideas, plans, whatever, we'll be happy to help on starting if you want to launch a Docker image on your laptop and play a bit with Dgraph.
Thank you. Kevin, do you want to kill this guy? I'll let you do it. We're all good.
Yes, so image is script available, so it's based on the DRG, which is the public GitHub repository.
It also requires there to be running Dgraph on your machine.
So